Hello students, welcome back. Previously we completed section 1. Now let's go to section 3, inverse trigonometry of acute angles. So basically, instead of calculating the distance from the angle, we are going backwards. We are finding out the angle. By the way, these are the definitions of trig ratios. Previously, I rewrote those into vertical over radius, horizontal over radius, and vertical over horizontal, but here I'm just keeping the same version. Yeah, it's the same. And then we can consider trig ratios as trig functions and sine of x, where x is a variable, a real number between 0 and pi over 2. Now, if you consider trig ratios as a function, then usually it's a lot better to use radian measure than degree measure. As a matter of fact, I'm a professional mathematician, but I've never seen anybody doing trigonometric functions and consider graphs and things like those with degree measure. Geometry, yes, but for trig functions, I haven't seen anything like that. So whenever you have trig functions and graphs, always consider the radian measure. And then graph of sine of x, yeah. You can use, graphing calculator app from 0 to pi over 2. And if you just plot it from negative infinity to positive infinity, then you're going to get a waveform. But they'll have to wait. We're going to consider those later in next lesson. Cosine starts from 0 and come down to, excuse me, I said it backward. Cosine starts from 1 and come down to 0. And tangent has vertical asymptote, start from 0 and then blow up to infinity. Remember those? Those are the basic angles. And here are the graphs. Now please note that all these are one-to-one functions. So we can take the inverse functions here, as long as we are staying in this domain. If you go outside of this domain, and these functions, sine, cosine, and tangent, will not be inverse function, not be one-to-one functions anymore. Therefore, you cannot get inverse functions, so you'll have to do some restriction. But for acute angle, no problem there. They're all one-to-one functions, so inverse function exists. So we simply take the inverse. Then what happens? Domain becomes the range, range becomes the domain. And then we have so-called inverse sine or arcsine function, which has graph like this in red. Please note that blue graph is graph of sine function, and then red is the graph of inverse sine function or arcsine function. Both are valid expression. This expression and that expression, both are valid expressions, widely accepted. And then they appear in your calculator as well. Using the second floor function, you can calculate inverse sine value or arcsine value. We're going to do some exercises like that shortly. And finally, make this observation. These two graphs are symmetric with respect to the diagonal y equals to x. Here we have cosine function and inverse cosine function. Blue is cosine function, red is inverse cosine function, and symmetric with respect to the diagonal y equals to x. Tangent function and inverse tangent function, or arctangent. Tangent function has vertical asymptote, blowing up to infinity with pi over 2. Arctangent function behave the other way around. It has horizontal asymptote. So vertical asymptote x is pi over 2. Vertical, the horizontal asymptote, y is pi over 2. And then, of course, those are all symmetric with respect to the diagonal y equals 2x. By the way, why is that? Why do those inverse functions have to be symmetric with respect to the diagonal? Well, if you fold this graphing paper along the diagonal, x-axis will be mapped right on y-axis and vice versa. But that's precisely the action the inverse function is doing. X is going to y, y is coming back to x. So geometrically, exactly the same folding action have to match. That's the easiest way to understand those. Anyway, we saw some of those graphs, and then we can use this inverse trick to do some application problems. Alright, find out inverse sine of 1/2. What is it? Well, pick up your calculator and use second floor functions to get this inverse sine of 1/2. Figure it out, what do you get? If you set it in the degree mode, you're going to get 30 degrees. In radian mode, it will be pi over 6, because sine of pi over 6 is 1/2. Next, inverse cosine of square root of 3 over 2. What do you think is this? Well, use your calculator again. What do you get? If you set it in the degree mode, you're going to get 30 degrees. In radian mode, pi over 6. Inverse tangent of 1, how about that? Tangent of a certain angle is 1 over 1. What is it? It's going to be 45 degrees, or pi over 4. Of course, you can use calculator. Set it in degree mode, you're going to get 45 degrees. Set it in... Sorry about the typo. I wanted the alpha. Somehow I typed sigma there. Sorry about that. Okay, alright. We did some applications. No, not really. Not applications yet, just elementary examples. Here we have some application. Okay, alright. Is this really a worthy application? We'll see. A lighthouse is located on an island 2 miles off a straight shoreline. Express the angle formed by the beam of light and the shoreline in terms of the distance d in the figure. Estimate the angle theta if d is 1.6 miles. Alright, we have triangular figure. And then, let's see. Do we know hypotenuse? D is adjacent to this angle theta. 2 miles, that's opposite. Do we know the hypothesis? Do we know the hypotenuse? We don't. So inverse sine and inverse cosine will not work. Tangent of theta is opposite over adjacent. So if you're looking for theta, that's going to be inverse tangent of 2 over d. Okay, alright. And then answer the question. Estimate the angle if d is 1.6 miles. Alright, special case. Theta is inverse tangent of 2 over 1.6. What is this? Well, you can use your calculator to figure it out. I have my calculator here, so I'll calculate with Wolfram Mathematica. Arctangent of 2.0 over 1.6, and this is what I get, but this is radian measure. Wolfram does radian measure, always. So I have to change it into degree mode. .34 something Alright, that is my conclusion in this case. In a similar problem, if you have to find out an angle, then you'll have to use inverse trigonometry. Arcsine, arccosine, or arctangent, or inverse sine, inverse cosine, inverse tangent. I mean, both expressions are correct. Where are the expressions? Okay, inverse sine, arcsine, they're the same. Inverse cosine, arccosine, they're the same. Inverse tangent and arctangent, they're the same. It's just that in Wolfram Mathematica, it is set up as arcsine, arccosine, arctangents. So I use arc expression there. And depending upon your setting, the setting of your calculator, you're going to see either this inverse expression or arc expression. And then the key question is the same. Do we know the hypotenuse? If you don't, use tangent. Let's open up this cell and then let's check the answer. Yeah, inverse tangent of 2 over 1.6, so approximately speaking, 51.34 degrees. That'll conclude lesson 2.